I'm going to be explaining college majors to y'all. Today we are going to be talking about aerospace engineering. This is a degree that is so near and dear to my heart because one of my students is actually in university at a top university studying aerospace engineering, and she is on her study abroad trip, and I'm just so proud of her. I do want to plug and say if you want to work one-on-one, you can book with me where we spend dedicated time creating your entire roadmap, and it's very in-depth and very intense, but I want to ensure that you are leaving our session with everything that you need. So that is available if you want to work with me. But as always, if I am looking down, it's because I have my notes on my phone and I want to ensure that we spend this time together very intentionally. So let's just always start with the core focus. So the core focus of aerospace engineering is going to focus on the design, development, and testing of aircrafts, spacecrafts, satellites, and missiles. So you're going to study the physics of a flight, and you're also going to really understand the structural mechanics as it relates to two branches. And so that is going to be aeronautics engineering, which is the focus of flight within the Earth atmosphere, and astronautic engineering, which this is going to focus on the travel in systems beyond the Earth atmosphere. Now, let's talk about some labor and statistics data that I think is very important for you to know and understand. So, the median salary is going to be about $128,000 a year. And the projected growth from 2022 to 2032 is going to be 6%. Now, there's only going to be about 3,800 new jobs opening within this field. So it is very competitive. And I also want to add, as the different global shifts change, this is going to be affected as well. Now, a global trend that is also important to name and note is that the commercial space industry is projected to reach 1 trillion US dollars by 2040, and this was projected by Morgan Stanley. And so the top countries that are heavily investing in the space industry or aerospace or aeronautics is going to be the United States, China, India, the UAE, and Japan. Now, let's shift our focus to speak about some career pathways within this industry. So, you can be an aerospace engineer, and this is where you're going to work directly on the aircraft or the spacecraft. And this is going to average about $128,000. Now, let's talk about some other career pathways. So you can be a flight systems engineer where you're going to develop control systems for flight stability, navigation, and automation. You can also be a structural analyst, and you are going to test stress tolerances, materials, and structural safety. You can also think about a mission analyst, and you're going to design trajectories, communication systems, and orbital mechanics. You can also decide to be an aerospace project manager, so you're going to lead the cross-functioning teams as it relates to research and development and production. Now shifting our focus to the industries that are going to be heavily hiring for aerospace engineers or in the aeronautics department. You have aviation, of course. This can be from a commercial perspective, private perspective. Also, space tech is going to be extremely huge. And I want us to challenge ourselves, not only focusing on what it looks like nationally or domestically, but let's think about this from also an international perspective. You can work in research and academia. Also, you can work in manufacturing. So this is where you're going to be testing materials and component designs. Now, if you want to go the graduate route and consider some advanced degree pathways, you can get your Master's of Science or your PhD in aerospace engineering. You could get a Master's of Science in mechanical engineering. You can get an MBA with the concentration in engineering management. You could also get your Master's of Science in Systems Engineering. You could also get a Master's of Science in Space Studies or Astronautics. Now, some professional organizations that you should consider researching and exploring. The first one is going to be the American Institute of Aeronautics and Astronautics. There's also the SAE International. You can, of course, explore NASA and a lot of the professional organizations or community events that they do. I know in Houston, NASA is really huge because Houston is a space city. And then there's also the American Society for Engineering Education. Now, shifting our lens to what are some of the tech stacks that you are going to need in this career path as well as this college path, especially as we're thinking about the innovation of AI and technology. Of course, aerospace engineering is going to be one of the trailblazers in that realm. So, some design and modeling tools that you should consider is going to be CAD softwares or aerospace softwares, NASA OpenForm, also MATLab or simulink. Some programming tools that you should consider is going to be Python or C++, also C squared, um, and LabVIEW. And some emerging tools that you should get familiar with or just like dip your toe in is going to be digital twin platforms or any machine learning frameworks that are going to directly intersect with aerospace engineering, and also get familiar with the satellite tracking frameworks and softwares. That is it for our majors explained today. Again, if you are looking for one-on-one consulting and you want to work with me personally, the link is in the bio.